All right, hi everyone. So here are the notes that we're going to be taking today. Here's the title, Exponential Growth and Decay. I recommend for you guys to take out your notebooks, copy down these notes as I go through them, and just make sure you're following along. Ask any questions, put any questions that you may have on the side, and then make sure to ask them to me. All right, so we're going to start off with this T-chart here, exponential growth and exponential decay. Those are going to be the two different types of functions that we're going to be talking about today. So when we're working with exponential growth, it's really important to consider this formula. This is the formula, it's the equation you're going to be using if the scenario given to you is an exponential growth problem. So y is equal to a times 1 plus r raised to the exponent of x. So this x, very important, it is in the exponent. And then if we jump to the other side, exponential decay, this is the formula that you're going to be using if you're working with an exponential decay problem. Y is equal to a times 1 minus r, all raised to the power of x. So we see here, 1 is being added to r, whereas on the decay side, 1 is being subtracted from r. And those are the two formulas. Again, they may seem a little bit random right now, but once you get to the word problems in a second, you'll see how we have to, from the word problems, we have to plug in or substitute, some of the values for the variables that we see here. So let's actually talk about those variables now. So the variables are a, r, and x that we see here. So a is going to represent an initial amount, and that's actually going to be true for growth and decay. A represents that initial amount. Let's jump down to x. X here, the exponent, that is always going to represent time, the amount of time it takes in the question that is being given to you. So any variable that you have that represents time, you're going to substitute it in there. And then r is what's going to change whether you have a growth or decay problem. So r in an exponential growth is obviously going to represent the growth rate. Usually it's given to you as a percentage. And R in the decay problems will represent the decay rate. Again, these will be percentages, and then your job will be to convert those into decimals. All right, so make sure you guys jot down these notes. We're going to be using them. They're going to be very important as we jump into the examples. All right, so let's go ahead and let's get started with example 1. So example 1, these questions are going to be word problems. So I'm going to go ahead and just read it out for you guys. Example 1 says, the population of hometown, so that's pretty much just a city, in 2016 was estimated to be 35,000 people with an annual rate of increase of 2.4%. There are two questions that example 1 is asking of us. The first question is, what is the growth factor for hometown after 1 year? The second question is, use the equation to estimate the population in 2020. So we're going to start off with question number 1 that asks us, what is the growth factor for hometown after 1 year? So first thing that you should be asking yourself, again, this is a word problem, so we want to create some type of equation from this word problem. So you should be identifying or trying to figure out, is an exponential growth or an exponential decay equation going to be most useful here? You should be telling yourself that an exponential growth function would be most useful. There's a couple ways how you could have known that. For one, the question itself does say growth factor. What is the growth factor? And also the question tells you that there has an annual rate of increase, right? So we are growing here, we are increasing. So we know that we want to use essentially this formula. Let me get my different colored pens out. This one's new though. Okay, so we're going to be using the y is equal to a times 1 plus r raised to the power of x. Now all we have to do is, from our word problems, we need to substitute in the values for the variables and then just do some algebra to solve. So let's try to figure out, what is my a value going to represent, what is my r value, and what is my x value going to represent. So remember, a represents, if you go back to the top of your notes, a represents the initial amount. So in this word problem, the initial amount of, in this case, people would be 35,000 people. So I would say 35,000 is my a value. My r value, if you go back to the top of your notes, r represents your growth rate. R represents your growth rate. So here, this population is growing at an annual rate. Remember, annual means every year, at an annual rate of increase of 2.4%. So my growth rate is 2.4%. And as I said earlier, those percents, before you can substitute them into your formulas or your equations, you have to convert these percentages into decimals. So 2.4% as a decimal, remember you take your decimal point and you move it twice over. So that's how you convert a percentage to a decimal. So this is actually going to be 0.024 as a decimal. That's my R value. And my X value, that is the amount of time. So in this question, you have to look here. It says, what is the growth factor for hometown after 1 year? So the amount of time that they're asking me for is after 1 year. So my X value is actually going to be 1. All right, now that you have your A, R, and X values, all you have to do is substitute them in and then do some algebra to simplify. So this one, once I put in my substitute in my values, it'll be y is equal to A, I'm going to plug in 35,000 times 1 doesn't change, plus my R value, which is 0.024, all raised to the power of X, which in this case is 1. Remember, you always use your order of operations, so you're going to work inside of parentheses first, then do your exponents, and then multiply it by 35,000. So this will be 35,000 times 1.024 raised to the first power. 1.024 raised to the first power is still 1.024. So all you have to do is take your calculator, multiply those two numbers together. I have my calculator here. Again, you guys should be following along with these. So I'm going to do 35,000. It's a little hard to see, there's a glare, but it's 35,000 times 1.024, and that essentially gives me 35,840. So that 35,840, what exactly does it represent? It represents the growth factor for hometown after 1 year, which if you think about it, makes sense. In 2016, there were 35,000 people. If we know that annually we increase by 2.4%, the population does, then after 1 year, you would ideally get something that's bigger than 35,000. So again, 35,840, that represents the growth factor after 1 year. Let's go ahead and work on that second problem. All right, let's go ahead and let's work on example 1, but problem number 2. So you should have the problem there at the top of your notes. The question is asking us to use the equation to estimate the population in 2020. So what we're being asked to find is, what is the population in 2020? So obviously, my A, my R, and my X value, we have to figure out what they are. Again, we have to consider, are they going to change? Are they going to be different? Are they not? And then figuring out which equation would be best to use. So based off of what's given to us, we know that we are still working with a population that is increasing by 2.4% every year. So my formula, my equation, that's going to remain the same. I still want to use this one. Y is equal to A times 1 plus R raised to the power of X. Now we need to identify, are my A value, R value, and X value going to change? So does the initial amount of people change based off of what they told you in question 2? Your answer to that should be no. So this is going to be 35,000 still. Does your growth does your growth rate change based off of what they give you in problem number 2? That also should be no. So this is going to still be 0.24. I'm still growing by 0.24 or 2.4%. Now, your X value, the amount of time that they are asking you for in this question, is that one going to change? This is when it gets a little bit more tricky. So again, the question says, use the equation to estimate the population in 2020. You have to think back to yourself. What was the original year that they gave you in the word problem? The original year was 2016. So from 2020, if they want to ask you, they're asking you for 2020, and you started in 2016. How many years have passed between those 2 years? Answer should be 4. So your x value in this case is going to be equal to 4. Make sure you do not plug in 2020 as your x value. That's not the amount of time, that's the year, but it's not the amount of time that has passed. So your x value would be 4. All right, we have a, r, and x. Again, after this point, you just substitute in those values. So y is equal to 35,000 times 1 plus 0.024 raised to the 4th power this time. Order of operations, as always, 35,000 is equal, multiplied by 1.024 raised to the 4th power. You should have out your calculators. First take 1.024, raise it to the 4th power. You're gonna get most likely a really long decimal, multiply that by 35,000. And once you have, actually I can do it here so that you can see. So again, you take, oops, a little blurry. Let me try to focus it a little bit. No, there's a glare. All right, but pretty much you're gonna take that 1.024, raise it to the power of 4. And again, you get a really long decimal. It should be something like that, 1.0995, so on. Just multiply that answer by 35,000, and it leaves you with approximately 38,482. Again, what does that value represent? It represents the estimated total population in the year 2020. All right, so those are 2 types of problems that you're going to be getting. I only went over one example, one exponentially growing example. Exponential decay are very similar. All you have to be mindful of is the different equation that you're going to use. All right, let me know if you have any questions. Bye.